everybody. In this video, we're going to learn how to calculate the standard deviation for a data set. So take 3 deep breaths and let's make this math easy. Okay, so when we're calculating the standard deviation, there is a formula for it, but I think that it's easier to calculate the standard deviation by following the steps that I've listed here. So we're first going to find the mean, then we find the deviations from each data point from the mean, then we square those deviations and add them all up, divide by the number of data points minus 1, and then find the square root of that. So if I wanted to find the standard deviation of these numbers, I would first need to find the mean. So I would add them all up and I would say 3 plus 4 plus 10 plus 0 plus 2 plus 5 gives me the number 24. And when I divide that by the number of numbers in my data set, which is 6, this tells me that the mean equals 4. Now, the goal of calculating the standard deviation is to look at how spread out the data set is. So that's ultimately what the standard deviation means. And to calculate this, we find the deviation of each data point from the mean, because the mean tells us where the center of the data is, and we want to look at how far away each of these data points is from the center. So to calculate this, you take your data point and you subtract the mean. So when I do 3 minus 4, this tells me that the number 3 is 1 unit below the mean. If I do 4 minus 4, that tells me that the number 4 is 0 units away from the mean, which makes sense because it is the same number as the mean. If I do 10 minus 4, this gives me the number 6, which tells me that 10 is 6 units above the mean. And then I can do 0 minus 4 to get negative 4, 2 minus 4, which gives me negative 2, which basically says that 2 is 2 units below the mean. And then if I do 5 minus 4, I see that 5 is 1 unit above the mean. So these numbers here are called the deviations. And if I were to add up all of these deviations, it would end up equaling 0 because some of them are negative, some of them are positive, and the way that the mean is calculated, all of the deviations will ultimately add up to 0. But that doesn't mean that all of the numbers are 0 away from the mean. In fact, some of them are pretty far away from the mean, like 10 is 6 units away from the mean. And so what we do to get rid of the negatives is we square all of these numbers. So we take all of the deviations and we square them, and we get positive 1, 0, 6, positive 16, 4, and 1. Because when you square a negative number, a negative times a negative equals a positive. And now that we don't have any negative numbers, now we can add these all up and find the total amount of deviations. So if I go 1 plus 0 plus 6 plus 16 plus 4 plus 1, this gives me the number 28. And this is the total number of squared deviations for the entire data set. And so now I'm going to take this number and I'm going to divide by the number of data points that I have minus 1. So it's kind of like we're averaging the squared deviations, except that we're dividing by 1 less than the number of data points. And this is just because of the way that the standard deviation formula works. And so since I had 6 data points, I'm going to divide by 5. And then my last step is going to be to square root this. So if I do 28 divided by 5, and then I square root that, what that gives me is the number 2.366, and the decimal keeps going, but that's good enough. And so this number is the standard deviation for this data set. And in our later videos, we'll talk about when we use the standard deviation and why it's useful. But for right now, we can just know that this number describes how spread out this data set is. So why don't you guys try this one on your own? Pause the video, calculate the standard deviation, and then restart it to see how I would solve it. Okay, so on this one, to calculate the mean, I'm going to do 23 plus 28 plus 27 plus 23 plus 24 plus 26 plus 24, and that gives me a total of 175. And to find the mean or the average, I'm going to divide this by 7 because there are 7 data points. And when I divide 175 by 7, I get a mean of 25. So now I'm going to calculate my deviations by doing 23 minus 25, which is negative 2, which basically says 23 is 2 units below the mean. 28 minus 25 is 3. 27 minus 25 is 2. 23 minus 25 is negative 2. 24 minus 25 is negative 1. 26 minus 25 is positive 1. And 24 minus 25 is negative 1. So these are all of my deviations, and now I need to square my deviations. So negative 2 squared is positive 4, 3 squared is 9, 2 squared is 4, negative 2 squared is 4, negative 1 squared is 1, 1 squared is 1, and negative 1 squared is 1. So these are my squared deviations, and now I'm going to add all of these up and divide by 1 less than the number of data points and square root that to find my standard deviation. So when I add all of these up, I get 24 total for my total squared deviations. And I'm going to do 24 divided by 6 because I had 7 data points. And when you're calculating the standard deviation, you divide by 1 less than the number of data points. And so that gives you the number 6. And then we're going to square root that. So 24 divided by 6 is 4. And if I do the square root of 4, that equals 2. And so the standard deviation for this data set would be 2. And again, this number basically describes how spread out the data set is from the mean or the middle of the data set. So I'm going to go through 3 more really fast examples to show you guys how the standard deviation number compares. So for example, if I was going to calculate the standard deviation for this data set, I would find the mean by adding 76 to itself 4 times, divide by 4, and that would tell me that my mean is going to be 76. When I find the deviations, each one of these numbers is 0 away from the mean because 76 minus 76 is 0. When I square those, I'm going to get zeros. And when I add them all up, I get 0. And then I'll do 0 divided by 3 because I had 4 data points. And when I square root that, 0 divided by 3 is 0, and the square root of that equals 0. And so if you have a standard deviation that's 0, what that means is that all of the numbers are the same as the mean. So 0 is the smallest standard deviation that you could get. And these next 2 examples will show how bigger standard deviations correlate with bigger deviations. So when you find the mean of these 5 numbers, the mean ends up being 14. When you find the deviations, 15 minus 14 is 1, 11 minus 14 is negative 3, 20 minus 14 is 6, 16 minus 14 is 2, and 8 minus 14 is negative 6. And so when you square all of these, you get 1, 9, 36, 4, and 36. When you add them all up, you get 86. And then you do 86 divided by 4 because there were 5 data points and you always do 1 less than the number of data points. And so if I do 86 divided by 4 and then take the square root, I get a standard deviation of 4.63. Now let's compare that to a different data set that has the same mean but a different amount of spread. So if you were to calculate the mean for this data set, this mean would also be 14. But when you calculate the standard deviation is different because this data set is spread out in a different way. Because I'd say 14 minus the mean is going to be 0. 15 minus the mean will be 1. 15 minus the mean is 1. 12 minus the mean is going to be negative 2. And 14 minus the mean is 0. When I square these numbers, I get 0, 1, 1, 4, and 0. And when I add them all up, I get 6. and I'm going to divide by 4 because there were 5 data points and 4 is 1 less than 5. And then I'll find the square root of that. And so when I do 6 divided by 4 and then find the square root, that gives me a standard deviation of 1.22. Now notice on this example, the mean was 14 and all of the numbers were pretty close to 14. And that gave us a standard deviation of 1.22. But on the previous example, we also had a mean of 14 and our standard deviation was 4.63. But this makes sense because this number that is describing the spread of the data is much bigger. And if you look at this data set, those data points are way more spread out than the data points in this one. And so basically, the idea is that the bigger your standard deviation is, the more spread out your numbers are. And we'll be talking more about this in later videos, but this is the basic way that you calculate the standard deviation. So I hope this was helpful, and I hope that you guys have a good day.